Welcome to the latest episode of Neighbors and Friends, a community TV education program that talks about education from the elements that are most important to students, parents, and the community. Our guest this evening is Dr. Mark Cardillo, the Executive Director of the Camille and Henry Dreyfuss Foundation, which supports science primarily in the chemical field, but also in other applied sciences through awards to professors and people active in the field. Mark, welcome to Friends and Neighbors, or Neighbors and Friends, I should say.
Thank you.
One of the reasons that I asked you to appear with us is that I'd like to investigate some of the educational opportunities in science and to get your opinion of whether you think it's growing or whether this is an area that young people should be looking into more fully. Students particularly.
Yeah, it's certainly one of the most exciting fields that there are. Scientists certainly feel that way, but more and more people are feeling that way. The world we live in is becoming ever more technological.
What do you consider the greatest challenges facing science graduates today as they come into this area of not so full employment? How's that affecting science graduates?
One of the really big challenges is to be able to pick an area that's both important and interesting. It depends, if we're talking about PhDs, it depends on what you did your thesis in, but you would like to be able to work on something that you really care about. Very good scientists generally have a passion for what they're doing, and certainly caring a lot about the outcome of what you do, whether it's the application to society or just a very important advancement of knowledge, is something that can generate a passion, and that makes generally good scientists.
How would you define the difference for the general audience between basic research and applied science? Everybody gets confused about that. Who's doing the work and who's doing the thinking?
Well, that's a little artificial, that difference. Okay, they're all doing the thinking.
Right.
Okay, there are engineering fields which have much chemistry in them. Then there are research fields, and those research areas often have many applied parts to them. And that may make the problems you're working on more interesting. And that if one of the questions we used to ask when I was at Bell Laboratories was, what would happen if you were successful in the problems you were investigating? Right? And it does make you think, this could possibly change the world, or this could advance knowledge in a way that everybody would realize.
In the interest of full disclosure, I suppose this is a good time to tell you that my father was a chemical engineer graduate of a major university. So I was certainly around him during a good part of his career as an applied scientist. Has your own experience as a research and applied scientist brought you personal acclaim in your field?
Well, a modest amount. Coming to Bell Laboratories when I was young was a great opportunity because there were so many smart people doing so many interesting things. You probably know that Bell Labs won a number, I can't remember whether it was 8 or so Nobel Prizes. They had about 14 or 15 Nobel Prize laureates. Having lunch with these people, talking about problems you might want to think was a very exciting thing. And that inspired me to do perhaps even better than I might have if I were somewhere else.
That's an interesting idea. How much of your personal accomplishments in the field, you're the executive director of a major science supporting foundation, can you ascribe to scholastic preparation when you were in undergraduate and then later on in graduate school?
Well, I think getting a position at Bell Laboratories or any other highly reputed research institution, one had to do fairly well in graduate school, and subsequently, perhaps.
And what
in
you're really
postdoctoral
saying
positions.
is not just fairly well, but
Well,
very well.
You had to come and give an interview talk and then talk to about 20 of their scientists over a period of 2 days.
That's pretty daunting.
And they had to
experience.
tell their leadership that this is a fellow we should hire.
Right.
So
How much of your experience came from working with other scientists and being able to contribute to a collegial atmosphere with your own ideas and your own experiences?
well, it's an interesting balance. It depends on what you're working at. It depends on where you're working. If you're working in the chemical industry, if you're doing research in the chemical industry, your goals are in large part well defined, even though the approach you take is yours. But in general, one works with a team. These are complex problems, and they have to be worked out, and they have to be tried, and then they have to be brought to a successful implementation. It's a little different if you're at a university. If you advance knowledge, that's already an accomplishment. You get a publication, right? And if you advance knowledge in important ways, your reputation will be quite high as a result.
So publication is as important in science research and development as it is in other fields of academia. What would you recommend for schools in the even in the elementary and secondary area for developing in students something more than just a passing fancy as far as science is concerned? How can you get them more intensely involved in science?
Yeah. Well, it's a very different and it's somewhat challenging problem. It's how to get young people interested in science. Science is intrinsically interesting if it's taught well. Teaching it well requires the teacher to be interested in science.
You mentioned earlier this evening when we were talking about doing the program, a new organization called Students to Science. That sounds like a fascinating program to me. And as you mentioned earlier, privately, it's growing. Could you tell us something more about that?
Well, there's an organization that's here in northern New Jersey, made of many retired and not quite retired scientists. New Jersey has a fair amount of chemistry industries and chemists as a result, drugs or oil refining, various chemistry manufacturing industries. So there are many chemists, professional chemists in the area. And they have decided that students need an opportunity to do really sophisticated, interesting experiments. Many schools can't afford the equipment.
Mm-hmm.
So they bring these students into their into their own building and provide them with equipment, provide them with a little bit of education, some lectures, and then these experiments to do on equipment that most of these schools can't afford to have. And the students' results in their tests are markedly improved. This is just one organization. There are many, many organizations.
Mm-hmm.
Happens to be one that we gave some money to recently to just help them move along in chemistry, and they're growing like topsy. It's a very popular enterprise.
That's very good news. And do you think that our scholastic science programs in America are rigorous enough for American students to compete in the world market for science?
Well, that's a very contemporary, interesting topic. There are major reports done for the National Science Board, which indicate that American students are falling quite a ways behind in science.
That's not good news.
No, it's not. There are efforts to improve this thing, and the efforts are all over the place. And some places are doing very well, and other places are falling behind. It's perhaps expensive, but it's a complicated problem, made more complicated by the fact that most boards of education are independent.
Right.
So there's not a national standard for many things.
Well, that brings up an interesting point, which is what is the best role for governments, federal, state, and local, to stimulate science education? What do you believe are the most effective avenues for outside help for supporting science education?
there's hardly anything that they can do that doesn't cost money.
Right.
So if the government and the people are not willing to invest, then there's not that much that can be done. They can set standards, okay? There are programs, there are federal programs which try to set standards and give support to states, which then are funneling that support to the local boards of education. But in general, there are many things which are required, particularly to help keep science teachers interested and up to date on what's going on in science. If they can do that, they can maintain the excitement for science, and that translates into an excited student population.
Isn't that one of the purposes of the Dreyfus Foundation, to encourage teachers at all levels by giving them
Yes.
awards and encouraging them to stick with their teaching experience instead of moving off into industry?
Well, it's okay. They move out to industry, and some of them move back in and become very effective teachers. Many teachers in our area are from places such as Bell Laboratories, which has reduced its commitment to science research, and many of those become science teachers in the schools. They're very good. But as I said, it's a complicated problem. If you try to run a government with thousands and thousands of independent parts, right? If you try to run a company that way, you'd find out it was almost intractable, and that's the way education is in this country. It's a hard problem. It's the fact that most teachers are quite dedicated. The question is, do teachers have enough of the fundamental skills and knowledge to be effective and to get students excited and want to learn?
There's some question, of course, about the fact that science was, for many years, primarily a male stronghold. How do you see the acceptance of women graduate students and women in general as far as science is concerned?
This is a historical problem, and the problem is not solved, but it is improving a lot. There are various ways to be a scientist, and perhaps some of the ways of being a scientist before were a little bit too strict and not allow for the various ways that people are intelligent, and perhaps that was unattractive to certain parts of the population. But as the biological sciences, as an example, have become more and more important, the number of women in biological science is enormous. In fact, it may be more than half. And as they've moved into chemistry departments and other departments, the fraction of women as faculty and the fraction of women scientists has improved. And science has improved as a result.
Oh, that's very good news, and I think some of the girls who are going to high schools and studying biology, chemistry, and physics will be pleased to hear that. Can you describe your responsibilities at the Dreyfus Foundation as its executive director? What do you do?
Well, there are different parts to it. One of them is the administrative part, and then we have many distinguished scientists as consultants, and we have programs. All these programs are reviewed, so it's like a peer review system in the National Science Foundation. They're reviewed, and then these scientists come in, and we finally make our decisions. It's an argument that goes on for the better part of a half a day or more. And then they recommend to the board. So we give out a lot of awards, and this is something that I oversee, let me put it that way. The other thing is I try and keep us involved in chemistry and the chemical sciences at the highest level. So I visit universities. I'm very fortunate to have come from Bell Labs, so I do know many people at universities, and so I can go out and see what's going on at the very best schools in terms of research.
Sounds mighty good to me. We're going to have to break right now for a few minutes, and thank you very much, Dr. Mark Cardillo. We'll be back in a few minutes.
In this economic downturn, libraries across New Jersey are reporting jumps in attendance of as much as 50% over the past year. Nearly 200,000 people use our computers every week.
Who'd have guessed that I'd be job hunting at my age? After spending several hours at home trying to upload my resume, I was just overwhelmed. My library showed me how to do it. Now I'm gaining back my confidence.
New Jersey libraries are transforming lives. Tell us your story.
Thank you, and we're back with Dr. Mark Cardillo of the Dreyfus Foundation, which supports research and rewards scientists and students in the sciences in America. There was one thing I did want to talk to you about, and that is in choosing candidates for the Dreyfus Honors and Support Awards, what are the criteria for an award?
Well, perhaps our most distinguished awards are for young faculty who have made a tremendous impact in their science at a relatively young age. And the criteria is great scholarship, but also great teaching. They have to demonstrate to us that they've been very good, innovative, effective teachers. But more than that, they have to have done something in the sciences which is really noteworthy. They have to move the field, as the expression goes.
Tell me about some of the criteria that would be these field-moving activities, without naming names. There's examples from some of the award winners.
There are scientists. One that comes to mind is a theorist who presumably has made great advances in quantum computing, which is something that still is not very clear as to what its value will be, and yet he has collaborated with some experimentalists, and they've actually demonstrated that such a thing is possible. That was a major advance in something that's quite far out. Maybe someday it will have important applications to cryptography and things like that.
It sounds like chemistry is moving in on physics and biology.
This is a theoretical chemist. But other chemists have, you probably are aware of the hype about nanotechnology. There are real advances in nanotechnology and nanoscience.
That's not somebody who looks after children.
Not nannies, nano.
Could you describe the significance of nano? I presume that means really, really big or really, really little, which is it?
Small.
Really,
Very
really
small.
Little. Okay.
So you're probably familiar with milli, which is 1,000th. It's the those rulers, and then it goes to micro, and then below micro is nano, 1/1000th of something. Right. And nanoscience, nanotechnology are particles which are only 1/1000th of a centimeter.
So you really could get an angel
They're
through
tiny. You can't see them.
You really get an angel through the eye of a needle. Yeah.
But more important, they can go through your bloodstream, through the blood-brain barrier. Now you can, if you can make these particles, then they can carry antibodies, for example, and you can make drug-specific, tumor-specific drugs which are carried by nanoparticles. That would be, for example, a major advance. Several scientists have come close to being able to do that. To have something that becomes accepted by the FDA, have to go through trials, et cetera, et cetera. That's complicated, but there are very exciting opportunities there.
It strikes me that designing the particles is not so much the issue as the delivery systems. Because if you've got something that is a living organism in certain media, what happens when it's exposed to air, for instance? I presume that's something that's still being worked on.
There are many aspects to this problem, but controlling what you have and then so that it will do what you want is, of course, a goal of many scientists.
What do you think, from your experience traveling the country and working with scientists at many different levels, that American science education is getting better, or is it stagnant?
Well, there's a lot of activity to improve it. In the last half dozen or maybe longer years, there are many National Academy of Science reports that indicate that American science education was falling behind, way behind most developed countries. And now there are a lot of efforts to try and improve the situation. There are some places, and I think we're in one of those places, where it's always been quite good.
Right.
But on the average, it has fallen way behind. And so there's a lot of effort encouraged by the National Academy of Sciences, funded by the federal government, to improve the science education, the teaching, and the level of scholarship that's required to be a good scientist.
The building that surrounds our studio here in Maplewood Columbia High School sent a team of young student scientists to the International Robotics Convention last year in St. Louis. And our team of 9th, 10th, 11th, and 12th grade students, 2 from each year, won the New Jersey competition, then went on and won the national competition in St. Louis, and came in second in the world competition, which is a great tribute to the New Jersey public school system and to the brilliance of these 8 young people and a very gifted teacher who came late to teaching, and we do encourage that in our state. If you have a career that you have completed to your satisfaction, you can become a public school teacher in New Jersey without going through a lot of hoops. What do you think are the best avenues for, or the most effective avenues anyway, for state and federal involvement in science education?
Okay, well, first let me congratulate Maplewood on a very, very, very high level of accomplishment.
Yeah,
and we are in an area where there are lots of school systems which have very good sciences. We're quite fortunate. Parents of children are quite fortunate that that's true. And as you know, the welfare of a country, the economic welfare of a country, is very strongly correlated to its technical ability, and particularly its science and engineering abilities. Right. Now, getting to your question, let me just, it is not so easy for the federal and the state levels to affect the details of science education.
Right.
They can set standards, okay, but they don't set budgets necessarily, and budgets are part of the problem. There are many people who claim that teachers need higher pay. That may or may not be so. I'm not sure about that. Certainly teachers need help in their education of themselves in the fields they're in. That costs money. If you're asking teachers to give up their summers to go and enrich themselves in the fields they're teaching, stay contemporary, sometimes they need financial support. So there are many aspects to a very complicated problem here. But there has to be a will on the part of the people to do this. And perhaps if the case were made more clearly that the relationship between economic well-being and the scientific and technical ability of a population are strong, maybe there'd be a greater will to improve science education.
No, that's an ideal world. One of the things that I've noticed in recent years is the number of students from other countries who come to America to study science and mathematics and the more technical subjects in universities. My own university in Texas has students literally from all over the world, and I'm sure that your alma maters are very similar. MIT, Cornell, even Stevens Institute, which you are a graduate of, a good New Jersey institution in Hoboken. If that's the case, if other countries are sending their best students to America, why aren't we encouraging our best students to go into science and engineering? And how do we change that formula?
Well, again, these are complicated. Let me not hedge, though. There are many ways to earn a good living in this country. And science is not easy. It's hard. Okay, so you really have to care about science. You have to feel, as I said before, a certain passion for understanding, for investigating, for discovering, right, and then resolving complicated problems. You might be tempted by other areas in which you can make an easier living. That may be one problem. Secondly, the standards for our students may not be that high. Many of the students we get, particularly, say, from China or from some of the European countries that are not very well off, those people really want an opportunity to improve their lives. And our graduate schools have always been very high quality. Our elementary education is fair compared to the rest of the world. Our high school education is fair compared to it. Colleges are on a par, but our graduate schools are still the best in terms of research and that level of quality. So they come here to have an opportunity, and a bigger fraction of them are going back to their countries every year.
Which is a good sign for international marketing and not such a good sign for American businesses.
Yeah. We still have a lot of young, very smart people from other countries who decide to stay here because of the fundamental like they have for the nature of our country.
Yeah. Given those aspects, what do you consider the greatest challenges that are facing science graduates today?
Graduates, high school graduates or college graduates?
Let's start with high school.
Well,
how does a good high school graduate get into a good science program?
Well, I'm sure that good high school graduates can get into good colleges.
Right.
And there are many, many colleges that have good science programs. They have to be interested in it and they have to follow up on that. If you're going to pursue research or at a higher level, whether it's at an industry or a research university, you then will have to go on to an advanced degree, such as a PhD. Okay, and there you have to really work at getting into a very good school, which does high-level research.
Let's see, you went from Stevens Institute to Cornell to MIT. That's a pretty good path.
I couldn't get a job.
Yeah.
I stayed in school. That's what my father said.
Well, some fathers have a better idea about things than others. My chemical engineering father was very disappointed that I didn't become an engineer, but he forgot what my math SAT scores were. What can we do now to stimulate primary educators in this country to involve more kids in science?
It would seem to me that the most important thing that a student will see is whether a teacher is really excited about what they're teaching. That makes great teaching. And I think that's true whether they're teaching literature or they're teaching chemistry or physics or any field. If the teacher is excited about it and enthusiastic, the students start to catch on to that. There must be something in there that's really interesting. We all know the joke about the horse, but I mean, it's true. Yes. And so how do you keep teachers at, say, the high school level excited and enthusiastic about their science? They have a hard life in terms of it occupying their entire energy to just stay involved with all these students and to teach them to grade their courses and everything. They may have summers, and if you could get them into summer programs where they could partake in a little bit of research, partake in a little bit of the frontier of science, and bring that enthusiasm, and that will come, that enthusiasm, bring it back to the high schools, the students will catch it.
Now that we've opened this can of worms,
yes.
When did your own involvement with science begin?
Well, I was lucky that my uncle was a physical chemist. And he was the head of the chemistry department at Stevens Institute of Technology, became provost, and so I wanted to go there.
So you were a legacy.
Well, I just wanted to go there because my cousins were the same age as my brother and I, and we used to play ball there all the time. So I just had an affection for that area.
Well, with that sign-off and recommendation for a good New Jersey education, I think we'll say good night to Dr. Mark Cardillo, and thank you very much for coming on Neighbors and Friends. And I hope we'll see you again sometime.
It was my pleasure. Thank you.
And same thing for you all out there. Come and visit. We'd like to see you. I'll sign off with my little quote, which I really like very much, from a very famous Irish poet whose name was William Butler Yeats. And Mr. Yeats said, "Education is not the filling of a pail, but the lighting of a fire." And with that, we'll say so long.